Okay, the next curve we are going to calculate the length of is the tractrix, right? Which is described by this complicated expression. The tractrix is an interesting curve. It's given by this setting here. So imagine that you have an object here, right? And you have a rope which has exactly distance, the length d, right? It cannot be stretched. And then you start pulling from this object in this direction, right? So the distance between the object you are dragging and where the position where you are is always constant. Well, as you pull from this object, the object is describing this curve, and this curve is a tractrix, right? So if you plot it like this, or you parameterize like this, the tractrix is a curve that is singular at 0, so it diverges like this, and then it goes all the way down to 0 at a certain point here, a, right? When x is equal to a, this is equal to 0, because you have 0 here, you have 0 here, a divided by a is 1, and the logarithm of 1 is 0. So this is what you have. Okay, this is like more or less the shape. So we're going to integrate this curve, the length of this curve, in this bit here from a half to a. Okay, we need to calculate, well, first we need the parameterization of this, of course. The parameterization is done as a function of x, okay? So we have here y of x, right? So the length of this is just the square root of 1 plus the derivative of x squared, okay? So we need to calculate what is the derivative of this, so substitute here and find this expression. So y prime is equal to, well, first of all, before calculating y prime, we're going to calculate the we're going to simplify the expression of this because we have a logarithm of equation here. We're going to express it as the sum of two logarithms like this, square minus x squared, right, minus the logarithm, a times the logarithm of x, okay, minus the square root of a squared minus x squared. All right, and now we can calculate the derivative of this. The derivative is a, and we can put up here the derivative of this, which is the derivative of the square root, which is minus x divided by the square root of a squared minus x squared. And down here we have the function a plus the square root of a squared minus x squared. Then we take the derivative of this, which is a divided by x, and we calculate the derivative of this, which, as I say, is minus or plus x over square root of a squared minus x squared. Okay, we now have to simplify this a little. All right, let's focus first on these two terms here, and forget for the time being the factor that you have here and the minus. So you have a minus a, multiplies whatever we're going to calculate now, which is x divided by, then you multiply this down by this square root, so you have the square of this, so a squared minus x squared, minus plus a times the square root of a squared minus x squared. This is this fraction here, and this fraction here is 1 over x. Remember, I'm factoring out this minus a, okay? So if I multiply, cross multiply this, I have x squared here, right, plus a squared minus x squared plus a, the square root of a squared minus x squared, and down here I have x times a squared minus x squared plus a square root a squared minus x squared. Okay, fine. Now this x squared simplifies here, and I can factor out 1a from here. And then I have a plus the square root of a squared minus x squared. And this expression down here, we have multiplied it before just to make now this simplification, but we can again factor out this square root. So we have a squared minus x squared multiplies the square root of a squared minus x squared plus a. Okay, so factoring out this square root. Okay, this is like the square of this square root. So this is what we have. And as you can see, this and these are the same, so that cancels. So at the end, we have this simple expression here, right? Which is the sum of this up to this factor minus a. So what we have to multiply here is this factor. So we have a over the square root of a squared minus x squared. And then we have to add x over the square root of a squared minus x squared. And that means that y prime of x is equal to x minus x is a squared over the square root of a squared minus x squared. Hang on a moment, because I think there might be something wrong here. Yeah, it is. There's something wrong because I forgot this x here. Okay, so there's an x here. Okay, so there's an x here. So there is an x here. Okay, and if I put this x and multiply here the numerator and the denominator by x in order to make the same denominator here, I have x squared here and I have an x here. So now it's correct. Okay, so this is the derivative, right? And the square of this derivative, well, of course, we have here a squared, well, we have here the square of this, actually with a minus, so we have minus 1 over x, and we have a squared minus x squared divided by the square root of a squared minus x squared. So this is simplifying minus the square root of a squared minus x squared over x. And this the square of this, y prime squared, is just a squared minus x squared divided by x squared. Okay, which is a squared over x squared minus 1. It's fine, because if we put it here, this minus 1 and this 1 go away, and then the length of this vector is simply the square root of this, which is a divided by x. Simply that, right? So the length we want to calculate is the integral from a2 from a2 to a of this function here, a over x dx. Right, so this is a times the logarithm of x between a half and a. That is a multiplies logarithm of a minus logarithm of a half. And since the logarithm of a quotient is the difference of logarithms, what we have is logarithm of a minus logarithm of a plus the logarithm of 2, and the answer is a logarithm of 2. Okay, that is the length of this tractrix in this interval, this particular interval that we've chosen.